Hi, welcome to the session about Project Klokwrk. My name is Damir Murat and I work for Kroz, a company based in Zagreb, Croatia. Here at Kroz, we recently decided to start and invest in Project Klokwrk, one of our open source initiatives. In this session, I will try to explain what is Project Klokwrk, feature it contains, and we will dive into some of them in more detail. In the end, I'm hoping you will have a solid idea about Project Klokwrk and possibly how it may help you in your own work. So, what is Project Klokwrk? If you look at the projects page on GitHub, you might get some idea. Nevertheless, I will try to explain it a few bullet points. First, Project Klokwrk is a working example of a complex microservices-based system. It is not strictly bound to the Axon, and it can serve as an example, at least some parts of it, for projects that do not use Axon at all. Related to Axon, Project Klokwrk implements an elaborate example of distributed CQRS event sourcing system, where Axon application is distributed in command-side, projection, and query-side parts. Each of these is a standalone application running in a separate JVM. We took this approach of Axon component distribution early on, since it is very interesting for us, especially in the light of microservices. Of course, it is still recommended to take the advice from Axon team and start developing your system as a well-structured monolith. And then later on, when and if the need arises, you can distribute your monolith. If you take that last distribution step, it might be useful to look at how this is done in Project Klokwrk. Project Klokwrk also demonstrates the usage of hexagonal architecture in Axon-based projects. For this purpose, we extended hexagonal architecture by adding some CQRS event sourcing flavor into it. Further, Klokwrk defines a structure suitable for the sensible organization of high-level project artifacts and modules that support multiple domains and subdomains. As we are working with many technologies and libraries, when there is a need for adding some enhancement, we are using Project Klokwrk as an incubator for implementing such extensions. Klokwrk is also a convenient environment for the investigation of new ideas and technologies. I mean, when you want to try something new, quite often it is hard to say if that something will work beyond hello world examples. If you have reservations about trying these new things in your current project, you might be missing a more elaborated environment for experimenting. You can use Project Klokwrk for these purposes. To summarize, with Project Klokwrk, we are trying to encode our lessons learned, provide answers for problems that we encountered, and possibly investigate some alternative solutions. To get expectations right, it is important to realize that the project is still in the early stages. You can explore it, pick up some ideas, or even use parts of it. However, be careful with that last scenario, as things can be changed significantly overnight. There are no stable releases yet. We believe that Klokwrk can help us at Kroz as a playground, showcase, and non-trivial guide for starting our own next projects. Hopefully, you might also find something useful in there. Okay, now let's look into more concrete details. We can start with the selection of the most significant technologies. For implementing runnable applications, Klokwrk leverages Spring Boot and Spring Framework. This is our primary choice. In the future, however, especially in the supportive and tooling domains, we might consider something else too. For example, something like Micronaut. Then, for implementing CQRS event sourcing aspects, there is Axon Framework and Axon Server, of course. For build purposes, Klokwrk uses Gradle, as we found it a more powerful and flexible alternative to the main. Besides, Gradle also excels in dependency management, which is very important for Klokwrk. For integration testing, we are using Test Containers library, which conveniently manage Docker container lifecycles during test execution. And finally, as our primary language, we are using Groovy. If you are coming from Java, Groovy is very easy to pick up. You should not have significant problems if you try to follow the code. Together with the Spock library, it is commonly used for testing not only Groovy, but even for Java applications. Some of the Spock examples we will see later on. At Cross, besides other languages, we are using Groovy for years, and it proves to be a very productive choice. Let's look now at some features of Project Klokwrk. We'll start with project organization. Here I have Klokwrk opened in IDE. At the top, there is a Klokwrk project, a root directory. It represents the entire system, and it maps to the whole problem space of our solution. As long as you have a single project for the whole solution, all related artifacts are placed under the system directory. Then, here we have a cargo tracker directory that represents our domain. That directory does not have corresponding build artifact like jar or var, but rather it just groups all artifacts belonging to the cargo tracker domain. As the implementation of the system grows, we might add additional domain grouping directories. There is one implementation caveat. Klokwrk uses Gradle as a build system, and out of the box, Gradle does not support artifact-less directories. Luckily, Gradle is flexible enough to support our layout by some custom scripting. However, a more straightforward solution is to use CoreDump, an excellent portfolio of Gradle plugins with its support for defining customized layouts of the Gradle-based projects. Here is CoreDump Gradle plugins homepage. Going back to the IDE, we can take a look at the settings Gradle file and minimal configuration which is required to leverage the CoreDump for supporting our desired layout. Stepping into the domain directory, we will find multiple modules belonging to the booking subdomain. Here they are. In this case, subdomain artifacts are organized by naming using domain prefix cargo tracker, followed by subdomain booking. If you want, you may also organize subdomains into grouping directories in the same way we did for domains. However, even if you do this, it is recommended to keep the same naming convention. That way, all potential naming conflicts at the level of concrete jar files can be easily avoided. In complex subdomains, we usually have multiple modules, and commonly they are not all at the same level of abstraction. In the Klokwrk example, modules with app suffix, which corresponds to application, are at the highest abstraction level as they represent runnable artifacts. Let me mark them as well. All other modules correspond to jar archives that are used as dependencies from application models. It might be obvious, but it is important to note how those subdomain libraries are specific only to the booking subdomain. They do not have reusability potential outside of that particular subdomain. With increasing number of artifacts, it is quite important to control and monitor dependencies between them. If you don't, you might end up with undesired dependencies or even with dependency cycles in the worst case. This can be done in several ways. You can use specialized tools like Structure 101 or Sonargraph, or even better, write appropriate tests, for example, with the help of ArcUnit library. Klokwrk uses Structure 101 because of its excellent dependency visualization capabilities, and ArcUnit tests are on the way. Let's see how this looks. Now we are in Structure 101 Studio, and here we have the Structure tab, where you can see an overview of all your artifacts known to the Structure 101 Studio. They are already laid out in horizontal lines, depending on actual existing dependencies at the bytecode level. If everything is all right, all dependencies go from top to bottom. And there isn't any pointing in a reverse direction. And there are no cycles neither. Structure 101 provides the ability to model your own architecture diagrams, where we can specify the desired architecture and focus only on relevant models and modules in that context. Here I'm hiding modules related to testing, and I added some additional wrapper cells for clarity, like subdomain libraries, domain libraries, generic libraries, etc. As we are exploring subdomain libraries, I will select the corresponding wrapper to see all related dependencies. There are three modules at the top level of abstraction in subdomain libraries. In general, they can use all modules below, but cannot use each other. It might be interesting to explore why do we have all these modules in the first place. Take, for example, Axon API module and projection model module. Axon API module contains classes that represent subdomain-specific commands and events. They are allowed to use Axon libraries as third-party libraries and are used by command-side application in case of commands and events, and by projection application for events only. On the other hand, projection model contains subdomain-specific JPA entities and repositories. As such, this module can be used from the projection application and query-side application. Therefore, both modules require quite different third-party libraries. In one case, it is Axon, in another case, it is JPA, and are used by different modules. Even if you think that both modules can be combined into one, significant differences in the usage and differences in third-party libraries may convince you otherwise. Here we have another interesting module, Cargo Tracker Booking Domain Model. Contrary to what you might expect from the name, it contains only domain value objects. There are no aggregates or entities or anything else from the domain, just value objects. I guess that name could be changed. Now, why is that? In CQRS applications, aggregates and entities belong only to the command side. They cannot be used either from projections or query side. But domain value objects can be shared among each of these. In one part, value objects are used for expressing the internal state of aggregates. They also can be used as building blocks for modeling events. Query side can also use domain value objects while describing query requirements. That broad reusability potential across whole subdomain is the main reason for extracting domain value objects into a standalone module. Okay, we finished with the booking subdomain, and I'll go back to IDE. Let's now quickly look into domain libraries. These are those 5 modules at the bottom of the Cargo Tracker directory. First, notice the names. They all start with the domain name, Cargo Tracker, followed by lib. Domain libraries contain infrastructural code at the lower abstraction level than subdomain libraries. They are reusable across the whole domain. If we have multiple domains using the same or similar technologies, domain libraries can be pulled down into generic libraries to make them more available. Besides, domain libraries can also contain incubating modules that will become generic at the end but for various reasons it is more convenient to keep them at the domain level temporarily. Here we also need to monitor dependencies and appropriate abstraction layers, similarly as we did for subdomain libraries. Nothing changed there. When we step down on the abstraction ladder further, we will find generic reusable libraries, and even further down, there are language extensions. The reusability potential of generic libraries is very high and is not tied to any domain. They also contain infrastructural code. Here we will find additions for various commonly and widely used third-party libraries. Because of high reusability, generic libraries can be used from any infrastructural code at a higher abstraction level. However, it is not expected that business-level domain classes like aggregates, entities, value objects, domain services, etc. use them. Domain-level classes should be agnostic to the technology and infrastructure as much as possible. In contrast, the situation is quite different with language extensions. Although being at the lowest abstraction level, they can be used anywhere in your code in the same way you use your programming language or its SDK. Therefore, domain-level classes are free to use language extensions as they want. In fact, some language extensions might be explicitly designed to support a more elegant implementation of domain classes. Let's now dive deeper. We'll take a look at how the application code is organized into packages. Do note that we are talking only about applications here. For libraries, some other rules are in play. Here we'll talk about hexagonal architecture. If you are not familiar with it, let's quickly look at the picture. At the center, we have our domain code. It is isolated from its surroundings as much as possible. We are using inbound and outbound ports and adapters for that purpose. Ports are just simple interfaces that are used by inbound adapters or implemented by outbound adapters. Typical inbound or driving adapters are web controllers or messaging handlers. Outbound or driven adapters commonly implement concerns like remoting or persistence. Details of these concrete implementations should never be visible in their outbound port contracts, as it should remain hidden from the domain. Probably the most important characteristic of the architecture is that all dependencies always point inward to the domain in the center. You might hear about onion or clean architecture too. They are quite similar to the hexagonal architecture. All these architectures share these primary characteristics of domain isolation from its surroundings. It is worth to mention that any of these architectures are very compatible with domain-driven design ideas and can help you implement them at the code level. If you want to know more, you can read that book, Get Your Hands Dirty on Clean Architecture by Tom Hombergs. It is not written for CQRS event sourcing applications, but rather for classical ones. However, in straightforward and very concrete terms, it explains hexagonal architecture very well. In Project Klokwrk, you can find described concepts and ideas from the book. In addition, Project Klokwrk slightly modifies hexagonal architecture by bringing some CQRS event sourcing flavor into it. Okay, let's take a look at how this manifests in the code. I'll open the top level package of the command side application. Here you will find domain and infrastructure packages, which is quite expected if you are familiar with hexagonal architecture. In domain package, we have cargo aggregate, while infrastructure package contains some glue code related to the Spring and Spring Boot. There is one more package at this level, feature. Klokwrk organizes business-related functionalities as features. You can think of a feature as a more coarse-grained concept than the use case. All closely related use cases are contained in a single feature. In our case, the feature that we have is named cargo booking. Under the feature package, we can find packages related to hexagonal architecture, adapter, and application. If we expand application package, we can see inbound and outbound ports together with application service that implements inbound port interfaces. Adapters are in adapter package, of course. There are inbound and outbound adapters. We can see here cargo booking web controller as an example of a driving inbound adapter. It depends and calls the book cargo port in. Which is implemented by the application service, cargo booking application service. As an example of outbound or driven adapter, here we have in-memory location register service. It implements find location port out, which is called by cargo booking application service. Without going into much more detail about concrete classes, this should be enough to get you a feeling how Klokwrk translates hexagonal architecture into tangible code artifacts like packages, classes, and interfaces. Using hexagonal architecture might be an attractive idea, as it looks like every significant component in the application has a well-defined placeholder. But there are also some rules regarding dependencies between artifacts. It is not allowed that each class or interface access anything that it wants. When you add additional CQRS event sourcing aspects, there are even more rules to follow. How can you ensure that rules will not be broken? Or how can you ensure that developers just learning about hexagonal architecture or CQRS and event sourcing can comfortably work with it without breaking it? This is the point where architectural testing comes in the picture. It will help if you had in place tests that verify all architectural invariants. Project Klokwrk uses ArcUnit library for this purpose. Building on top of the ArcUnit, Klokwrk provides DSL for specifying hexagonal architecture layers for CQRS event sourcing applications. There is support for several subtypes of CQRS event sourcing flavored hexagonal architecture, which correspond to the command-side, projections, and query-side aspects. Let's take a look at the test for the command-side application. This is a Spock test. If you never saw one, it might look somewhat weird or maybe even too simple. However, you can probably follow the code easily. In the test method called should be valid hexagonal CQRS architecture, actually this is a wrong method. I should be showing this one. Should be valid hexagonal command-side CQRS event sourcing architecture. We verify if our command-side application complies with architectural requirements. The test is very straightforward. All you have to do is to point DSL to the appropriate packages that correspond to the CQRS event sourcing hexagonal architecture layers. Calling a rule check at the end will ensure that all architectural requirements are satisfied. To understand how this works, we'll quickly look at DSL implementation. Okay, here's a method that interests us. Specify architecture command side. The method defines constraints for command side applications. First, it defines all relevant layers for command side application. And then it defines rules for these layers. For example, if we look at the rules for events, we can see that in command side application, only aggregates can use them. If you take a look what is with commands, commands can be used by aggregates, but also by application service layer, and so forth. If we go back to the tests and look at tests for query-side application, or test for projection application, you will notice that they are even simpler from the test for command-side application. This is so because query-side and projections have actually fewer layers. We'll turn our attention on a very different, but also quite important kind of testing. Integration testing. If you are using Spring Boot, you are probably familiar with Spring Boot tests. They belong to the group of integration tests. Spring Boot allows easy startup of application components that are exercised by the test. However, this does not help if you want to run tests in a more realistic environment, an environment where real, or at least almost real, infrastructural components are started for testing purposes. This is a domain of test containers library. At the beginning of the test, it will help you starting up appropriate Docker containers that represents your infrastructural components. Then tests are run, and finally test containers will clean up all these containers at the end. Let's look at one such test that involves Axon-related infrastructure. I will open a specification named cargo summary, which is the name of the feature, query application service, which is the name of test subject, and integration specification. Here's the test, and here is a relevant test method. Should work for correct request. This test verifies a single feature of the query-side application. In the setup phase, the test publishes an event to the Axon server and waits corresponding projection to finish. It then simply executes a query and verifies a response. Quite nice and relatively simple. To see the details of how infrastructural containers are brought up and executed, we need to look at the abstract parent class. Here, in a static initializer, we first create a Docker network. It isolates the communication of Docker containers used in this test from any other Docker containers that we might have already running. This allows us to run multiple Docker-based tests in parallel without worrying about communication clashes between containers. Support for parallel tests can dramatically improve the speed of text execution, which is always good and important. So, after the network is created, several other containers required for this test are brought up, and tests can be executed. So here we have a PostgreSQL server, which is brought up, then our database management application, which manages the database schema with Flyway, a library. Then we have Axon server, and finally projection application. So, this test that we are talking about belongs to the integration test of the query-side application. It is implemented as a Spring Boot test, which you can see from that Spring Boot test annotation, where Spring Boot manages the lifecycle of the query-side application. On the other hand, as we saw, test containers library manages the lifecycle of all other required infrastructure. Of course, there are much more details into it that needs to be implemented to make this usable. If you want to look at them and if you want to find more examples similar to this, take a look at the Klokwrk code. Now that we dealt with the integration tests for a single component, we want more. We want to test the whole system. Let's bring all applications up and use some external client to exercise them. But let's try first to see more precisely what we are trying to test now. We are still in the context of our booking subdomain. We are not dealing with the whole system yet. We just want to test all components from our subdomain in a way similar to the system test. We call this kind of testing component testing. You can think of it as a system testing, but on a smaller scale, at the scale of our subdomain. If you want to know more about component testing, there is a related presentation by Klokwrk, where you can look up for more details. Okay, so how these component tests for our subdomain look? And where should we put them? In project Klokwrk, under cargo tracker directory, there is cargo tracker booking test component module. Component tests are extracted in their own module, since they need to depend on all applications in the subdomain. Dependencies of this module are quite different from any other module in the subdomain. Therefore, we have a separate module. Here we have a booking component feature specification, and according to the name, the logical component that we are testing is the booking component, our booking subdomain. It doesn't matter if it physically contains multiple applications. All these applications still implement a single logical component, our subdomain microservice, which happens to be separated into 3 distinct runnable artifacts. Other than this, the test looks very similar to the previous test container tests that we saw, with one distinction: it is not Spring Boot test anymore. It uses test containers library for bringing up Docker containers of all applications and required infrastructure from the booking subdomain. After that, the test uses external HTTP client library for executing requests against the command side and query side of our subdomain. Besides standard component tests, there is another vital type of component test, event replay test. Event replay testing verifies that all types of events that you ever had in your system can still be successfully projected. I don't mean all events from your production event store, where you can have potentially billions of them, but rather all types of events from the production event store, which will be typically in the scale of hundreds or maybe thousands. The idea is to store all representative events in a file and publish them to the event store when the test starts, and then verify if all events are correctly projected. This means that your projections can still project every type of event that you have in the production. As you develop a system, every new event type should end up in that resource file. Here is a test. Booking component event replay specification. There is no abstract class in this case, as we are initializing all containers in place. There are also some helper methods. If we look at the actual test method, should replay RDBMS PostgreSQL projection, we will find that it first publishes all events that we have in our SS file, and then it polls for a global sequence event from a token stored at projection database. If the global sequence number matches the number of published events, the test succeeds. If you're wondering, Axon Server has necessary REST APIs from which you can extract events that you need for this kind of testing. Okay, we finished with testing and detailed look at some of the features. Let's now quickly enumerate what else can be found in Project Klokwrk, as we don't have time to look at details anymore. At the domain boundary, in the application services layer, Klokwrk defines generic API for specifying requests and responses. Besides allowing the definition of a payload, it also explicitly implements support for metadata, very similar to the Axon messaging API. We found that being able to use metadata at this level is quite often very useful. Then, there is support for resolving responses and exceptions through resource bundles, depending on the requested language. This includes proper structure for localized payloads and metadata in responses, and support for conventional resolving of business and non-business exception into messages. At the generic libraries level, we have some Groovy extensions that help create immutable objects and support simple mapping of data from one object into another. Quite often this is more than enough for data mapping purposes without requiring any additional library. Then there is a rather useful extension for the data source proxy library that includes support for Spring Boot configuration and implements a filter for ignoring not so interesting queries, for example queries that Axon uses for polling token star. There is also an opinionated Spring Boot configuration for Jackson library. By following some simple conventions, it allows Jackson usage without the need for Jackson annotations. Then we have some simple Axon extensions too. For example, Klokwrk provides enhanced Axon logging, which supports the correlation of log messages over the aggregate ID and sequence number, which is quite useful when looking in distributed and aggregated logs. Further, Klokwrk provides adapters for command and query gateways. In one part, they enable convenient sending of custom metadata through the gateways, and in the other part, adapters extract details from Axon's remote handler execution exceptions. Related to this, we also have traits for convenient drawing of business exceptions from distributed handlers across Axon server. There is more, but let's stop now as I want to spice up things at the end with a demo. In the demo, I will run our booking subdomain applications, and we will explore metrics and distributed traces of them. Except for reporting some issues in previous versions of related libraries, Klokwrk does not do much here. It merely demonstrates the usage of technologies, which is exactly one of points. Anyway, I found it very interesting to see actual traces of a distributed CQRS event sourcing application. To save some time, I already started command side, projection, and query side applications. In the background, I also started Axon server and Postgre database. If you want to do this yourself, take a look at the Klokwrk documentation. Here you can find a suitable tutorial. As of version 2.3, Spring Boot provides a very nice and useful integration with the Wavefront service from VMware. It is a diagnostic service entirely free for use. What is more impressive, it can be activated simply by providing an appropriate starter jar in your application. To be able to see distributed traces across Axon applications, you also have to add Axon tracing extension, as is shown here. To get some real data, I will execute dozens of command and query side requests. We have to wait for data to appear in Wavefront, which can take up to 2 minutes. From the application output, you can get the Wavefront link. It will take you to the Wavefront dashboard page. As we will not create any custom dashboard right now, we'll start exploring from Application Status page. Click on Applications menu and on Application Status item. First, we'll filter out our results for the last 5 minutes only. If you click on a tile with your system name, Wavefront shows all parts of it. Here we have tiles for command side, projection, and query side, and a tile that corresponds to our database. To see some metrics, we can go on the dashboard of the command side application. Here is a lot to explore. We'll take a quick look at the latency histogram chart. By hovering over labels in the chart, we can understand how many requests end up in particular percentile. To dig deeper, we'll take a look at the traces page. Here you can explore tracing spans for individual requests. Notice the trace service map that quickly shows all components involved in the request handling. For this particular request, we have command side and projection dealing with it. And finally, there is a panel displaying details of the request. Here you can see all the related spans with their exact timing. Note the color matches. Note that the color matches those from trace service map, so you can easily recognize which span request to which application. It is also very interesting to note asynchronous behavior of the projection application, which starts its work while the command side application is not finished yet. In summary, with Wavefront or similar tooling and services, we can quickly glance over application behavior, performance, and latency. This kind of information may be invaluable anywhere from the development to the production. When combined with ease of use, there are very little excuses left not to use them, as we just saw on the Klokwrk example. Okay, this is all I have. I'm hoping it was interesting and that you heard something useful and worth exploring in Project Klokwrk. With this in mind, I would like to thank you for your time and listening.